In the realm of geological sciences, establishing precise reference points for measuring time has always been a critical endeavor. Just as the kilogram was once defined by a metal cylinder in France, geologists seek tangible markers to delineate Earth's epochs. In a surprising twist, a small, unassuming lake in Canada may become the defining reference point for the dawn of the Anthropocene, the proposed geological epoch characterized by humanity's profound impact on the planet. Crawford Lake, located approximately 50 kilometers southwest of Toronto, is a modest body of water that one could easily overlook. Spanning just 250 meters at its longest point, it's a lake that a proficient swimmer could traverse in about 5 minutes. Nestled within a UNESCO Biosphere Reserve, the lake is surrounded by cedar trees, reconstructed indigenous longhouses, and a scenic boardwalk. Despite its small surface area, Crawford Lake holds secrets in its depths that could revolutionize our understanding of Earth's recent geological history. The lake's unique characteristics make it an ideal candidate for marking the beginning of the Anthropocene. Formed in a natural sinkhole created by the region's soft limestone bedrock, Crawford Lake reaches an impressive depth of 24 meters at its deepest point. This depth-to-surface ratio is crucial to its potential as a geological marker, as it creates a set of conditions unlike those found in most other lakes. One of the most significant features of Crawford Lake is its lack of water mixing. The lake's narrow, deep profile prevents wind from churning its waters, resulting in distinct layers that remain undisturbed. This stratification is further preserved by the absence of bottom-dwelling organisms that might otherwise disturb the sediment. As a result, each layer of mud that settles at the lake's bottom remains precisely where it falls, creating a pristine record of environmental changes over time. The lake's limestone bed contributes to another unique phenomenon that makes it an exemplary geological timekeeper. Each summer, changes in water chemistry triggered by warm weather and algae growth cause calcium carbonate to precipitate out of the water. These white, chalky crystals settle to the lake bottom, creating distinct annual layers reminiscent of tree rings. The alternating pattern of dark mud from fall, winter, and spring, separated by white calcium carbonate lines from summer, provides an incredibly accurate chronological record. Adding to Crawford Lake's suitability as a marker for the Anthropocene is the presence of oxygen at its bed. Despite the lack of mixing in the water column, oxygen-rich water seeps in through the limestone, creating conditions that preserve certain chemical signatures crucial for dating and environmental analysis. These unique characteristics have allowed scientists to reconstruct a detailed history of human activity in the area. By analyzing plant pollen trapped in the sediment layers, researchers have traced the arrival of indigenous groups and the introduction of corn cultivation. More recent human impacts are evident in changes to nitrogen isotope ratios and the presence of fly ash, both indicators of increased fossil fuel use in the 1950s. Perhaps the most compelling evidence for Crawford Lake's potential as an Anthropocene marker is the presence of plutonium in its sediments. Plutonium, an element almost entirely of human creation, provides a clear signal of the nuclear age. While trace amounts of plutonium can be found naturally, its widespread distribution is a direct result of nuclear weapons testing beginning in the 1940s and 1950s. In many environments, microbes can dissolve and disperse plutonium, blurring this signature. However, the oxygen-rich environment at the bottom of Crawford Lake preserves this plutonium spike with exceptional clarity. The proposal to use Crawford Lake as the golden spike, the official reference point for the start of the Anthropocene, came from a working group within the International Union of Geological Sciences in July 2023. This recommendation is the result of extensive research and comparison with other potential markers around the globe. The concept of the Anthropocene itself is still debated within the scientific community. Proponents argue that human activities have altered the Earth system so fundamentally, through the widespread use of plastics, nuclear technology, and fossil fuels, that we have entered a new geological epoch. Critics question whether these changes are significant enough on a geological timescale to warrant a new designation. Regardless of the outcome of this debate, the study of Crawford Lake and similar sites provides valuable insights into humanity's impact on the planet. The lake's sediments offer a high-resolution record of environmental changes, allowing scientists to track the acceleration of human influence on the Earth system with unprecedented detail. The potential designation of Crawford Lake as the Anthropocene's golden spike raises interesting questions about how we conceptualize time and human impact. Unlike previous geological markers, which often denote catastrophic events like asteroid impacts or mass extinctions, the Anthropocene marker would signify a gradual but profound shift in the Earth systems driven by human activity. If Crawford Lake is officially recognized as the reference point for the Anthropocene, it would join other significant geological markers around the world. These include the iridium-rich clay layer in Tunisia that marks the end of the Cretaceous period and the extinction of the dinosaurs. Such reference points are crucial for scientific consistency, allowing researchers from different parts of the world to align their findings and build a coherent understanding of Earth's history. The selection of Crawford Lake would also highlight the importance of preserving such natural archives. As climate change alters ecosystems around the world, sites like Crawford Lake become increasingly valuable for their ability to provide long-term environmental records. Their protection ensures that future scientists will have access to these crucial data sources. Moreover, the study of Crawford Lake and the broader concept of the Anthropocene encourage us to reflect on our relationship with the planet. By providing tangible evidence of human impact on geological timescales, it challenges us to consider the long-term consequences of our actions and potentially inspire more sustainable practices. As we await the final decision on Crawford Lake's status as the golden spike for the Anthropocene, its significance extends far beyond the realm of geology. This small Canadian lake serves as a powerful reminder of the interconnectedness of human activity and natural systems. It demonstrates how local environments can record global changes and how the actions of our species have become a force of nature in their own right. In conclusion, Crawford Lake stands as a testament to the power of careful observation and the unexpected places where we might find answers to big questions. From its quiet waters, we may gain unprecedented insight into humanity's place in Earth's long history, marking the moment when our species' influence became so profound that it altered the very fabric of our planet's geological record.